Okay, here is another practice problem for momentum that I just made up. So in this problem, I have a satellite in space traveling with some velocity. I made the velocity 1.1, negative 0.8, 2.1 meters per second. There is a gravitational field, so there is a gravitational force, but it's far away. Okay, so it's far from the center of the Earth. So I put it at negative 8.1 instead of 9.8 newtons per kilogram. The mass is 44 kilograms. And then there's also this rocket thrust of negative 25, 10, 210, 0 newtons. And this is at 0 seconds. So the question is, what's the momentum and where is it? Oh, I guess I should just find, I guess I need to say, I didn't say where it is right now. Let's say R1 is at 0, 0, 0. So it's at the origin. I just made that up. See, I can do that. I can make up stuff. So where is it going to be at 4 seconds, and what's the momentum? So the first thing we need to do is find the net force. So I can say F net is going to be Ft plus mg. So that's going to be equal to the vector negative 25, 210, 0 plus the mass of 44 times 0, negative 8.1, 0. So let's just write this down as a single vector, just for fun. Okay, so I get the x component is going to be negative 25. The y component is going to be 210. And then I have to add this in. So I have 44 enter 8.1 change sign times plus. And I get negative 146.4. And then there's no z component. Right. Now I need to use the momentum principle. So the momentum principle says F net is delta P over delta T. Or P2, which is what I'm trying to find, is equal to P1 plus F net delta T. So P1 is going to be equal to the mass, 44, times the velocity, 1.1, negative 0.8, 2.1, plus F net, negative 25, negative 146, I know I'm going to run out of room, 0 times the time interval, delta t, of 4 seconds. So 4 minus 0. So I can get the final momentum now. P2 equals. Okay, let's first do the x-coordinate. So the x-coordinate is going to be equal to this, 44 times 1.1. So 44, 1.1 times. Then I need to add this, negative 25, 4 times. That's 100, I should have known that. And then add that. And I get negative 51.6. Now for the y-coordinate, I'm going to have 44, enter, 0.8 change sign times. Then I'm going to have the negative 146.4 change sign, enter, 4 times, plus. And I get negative 620.8. And then finally I have 2.1. There's no force in the y direction, so I just get 2.1. Oh, I need to multiply that by, by 44. 44 enter 2.1 times. I get 92.4 kilograms meters per second. That's the final momentum. Okay, what about the final position? Here I can say V average equals delta R over delta T. So I want to find delta R. Delta R is going to be equal to V average delta T. Now, I really want to find the final R, so it's actually R2 equals R1 plus V average delta T, which is equal to, so now there's two ways I could do this. I could actually calculate the average velocity, or I could just use the final velocity. In this case, I think I'm going to use the actual average. So this is going to be equal to R1 is 0. So the actual average is going to be equal to P2 plus P1, that divided by 2m. Because P2 plus P1 is And then if I divide by the mass, I get the velocities. Then divide by 2, I get the actual average. So all I have to do is multiply that by delta t. So R2 is going to be equal to P2, which is this, negative 51.6, negative 620.8, 92.4, plus the initial momentum, which I actually never calculated. So let me just put this as divide by the mass. Did I calculate that? I didn't. So I just divide all this by 44, and then I'll leave this as the velocity. 1.1, negative 0.8, 2.1, and then divide all of that by 2. And then add that to the vector 0, 0, 0, because that was initial. Okay, so let's put that in our calculator. Okay, let's do this x first. So I have 51.6, enter, 44 divided by, change sign. That's that. And then I'm going to add the 1.1, 1.1 plus, and then I'm going to divide by 2. And I get negative 0.036. Now for the y direction, I get 62.0.8 change sign, enter, 44 divided by, and then 0.8 change sign plus 2 divided by. I get negative 7.45. And then finally for the y, I get drop 92.4, enter, 44 divided by 2.1 plus 2 divided by. Oh, I didn't multiply by delta t. Arg. So all of that times delta t of 4 seconds. That's fine. So I get 2.1. Yeah, because it didn't. Yeah, it didn't change. Okay, that makes sense. And then I have to multiply that by 4 to get the answer. Okay, so that's fine. Let's do that. So I get 4.036 times. I get negative 0.144. And then I get 7.45, enter 4 times, 29.8 negative, and then 2.1, enter 4 times, 8.4 meters. And that's the answer. Okay, so let's just review really quickly. I have two forces, and so for those two forces, I found the net force. And then with the net force, I set that equal to the change in momentum over the change in time. With that, I can find the final momentum at the end of the time interval. Now to find the change in position, I need the average velocity. So that's just going to be v1 plus v2 divided by 2. Multiply that by delta t and add the initial position, which was 0, 0, 0. Then I get the final position. And that's what I did. And I might have made a mistake because I got a little confused with the masses, but there you go.